Welcome to another video. Here I'll be continuing this 1985 AP Calc BC multiple choice part of the exam. Okay, I believe we left off on number 16, so let's get started. Which of the following functions show that the statement if a function is continuous at x is equal to 0, then it is differentiable at x is equal to 0 is false. I'm guessing right away there must be some sharp turn there, or is this continuous there? Okay, so let's see. F is continuous at x is equal to 0. So this would be 1 over x to the 4/3. So it's not continuous at x is equal to 0. Okay. This also is not continuous at x is equal to 0. So I believe we can eliminate those. Okay. So how about this one? This is continuous at x is 0. This is continuous. This is continuous. How about, is it differentiable at x is equal to 0? Okay. This one we know is differentiable at x is 0. Okay, this is just the... Okay, if we find f prime, it'll be 3x squared. It exists at x is 0, so get rid of that. This would be 4/3 x to the 1/3 power. Okay, when x is 0, the derivative exists. So by process of elimination, it'll be this one. And we can confirm, if we do power rule, it'll be 1/3 x to the negative 2/3 power, which is 1 over 3x to the 2/3 power. So x cannot equal to 0, right? So C. If f is x ln of x squared, f prime is what? This is simple product rule and chain rule. First d second plus second d first. So first, d second was the derivative of ln of x squared. That's 1 over x squared times 2x. The 2x from the chain rule, because we had to differentiate the inside, okay? Plus second d first was derivative of x is just 1. Okay, so here we would combine to a 2x squared. 2x squared divided by x squared is just 2. So it'll be 2 plus ln of x squared. 17 is B. We have this integral sine of 2x plus 3 dx. Okay, we could do a substitution. U is 2x plus 3. Okay, if you don't know how to do it in your head, I'm just going to do it in my head, and we can always just differentiate to check that we get back this, right? So the integral of sine is negative cosine, right? So negative cosine of 2x plus 3, and then we need to divide by 2. Plus c. Let's differentiate this and make sure that we get back this. Derivative of cosine is minus sine, so this would become positive, right? So positive sine of 2x plus 3 over 2 times derivative of the inside, so times 2, that times 2 would get rid of this 2. So we got the same thing, okay? So it'll be minus cosine 2x plus 3 over 2. Is 18c? Yes, okay. F and g are twice differentiable functions such that g is e to the f of x, g double prime is h of x e to the f of x. The h of x is equal to what? Okay, so we're given g. Let's find g prime, because we eventually need to get to g double prime, so let's find g prime first. G prime of x is what? Derivative of e is just e, but we need a chain rule, so times f prime of x. Okay? Now let's find g double prime. Okay? We need the product rule here. So first, the second derivative of f prime is just f double prime, right? Plus second d first. Derivative of this guy is, once again, e to the f of x times f prime of x. So we can rewrite this as e to the f of x times f double prime of x plus 2 actually not plus 2, sorry. This will be e to the f of x, f prime of x, quantity squared. Okay, so we simplify, we can factor out this e to the f of x because we want to make it look like this, right? E to the f of x times, it'll be f double prime x plus f prime of x quantity squared, like that. Okay, so this would be our h of x. And which one is that? That is D, yes. Okay. Excuse me. Graph of y is f of x. On a closed interval 2 to 7 is shown above. How many points of inflection does this graph have on this interval? This is f. Let's find where it changes concavity. Okay. So here it's concave up. Then there's probably some point over here. Let's mark it. Then it becomes concave down over here. And then at some point over here, it's concave up again. So over here it's concave up. Then over here it starts becoming concave down again. Okay, and that's it. Okay, so we have, looks like it's 3 points of inflection. Okay, because the concavity changes 3 times. Right, that's how we do that one. Let's move on. I'm trying to put this on the bottom. Okay. If f of x sine, the integral f of x sine x dx is negative f of x cosine x plus integral 3x squared cosine x dx, then f of x could be which one? This looks like integration by parts because it's a product of 2 functions. There's something, remember it's u dv is uv minus v du. This looks something like that, right? So let's try integration by parts. Okay, so it looks like they different, or actually sine and cosine you can differ. So it looks like if this is u dv, uv, v du. Okay, so it looks like u is f because they didn't integrate or differentiate that. They didn't differentiate f. Okay, so let's let u be f of x. Du would be f prime of x dx, right? So then dv is sine x dx. V would be minus cosine x, right? So our integral, let's call it I. Let's call this guy I so I don't have to rewrite it. I is equal to uv, so minus f of x cosine x, which measures that. And then becomes minus v du, so it becomes plus integral cosine x f prime of x dx, v du, okay? We have a cosine x dx, so f prime of x looks like is 3x squared. Okay, so f would be x cubed plus some constant c, so looks like it's B. That's a possible one. That's right. Okay. Area of a circular region is in. Okay, this looks like related rates right away, so let's keep track of what they give us. Area of a circular region is increasing at a rate of 96 pi square meters per second. So they give us dA dt is 96 pi. When the area of the region A is 64 pi, how fast in meters per second is the radius of the region increasing? So they want dr dt. Okay, so let's excuse me, write the formula for the area of a circle. That's pi r squared. Let's differentiate it. So b dA dt is 2 pi r dr dt. We have a dA dt. We want what dr dt is. How about r? Well, we can find r from A. This is pi r squared. So it looks like r is 8. Okay, so dA dt is 96 pi is equal to 2 pi times what's r? We found that as 8. dr dt is what we want. Okay? So then this pi can cancel with this pi. So it'll be 96 over 16 is equal to dr dt. Okay? So can we simplify that? It looks like what? This is equal to 6, right? So 22 is A? Yes. Okay, so we do that. Limit as h goes to 0, integral from 1 to 1 plus h, square root of x to the fifth plus 8 dx over h is, how do we do this? Well, let's just, of course, start plugging in h is 0. What happens? We can get an integral from 1 to 1, meaning no area, so the top is 0, over the bottom is 0, 0 over 0, that's indeterminate, okay? So we can do L'Hopital's rule, okay? So let me try to squeeze it here. Limit as h goes to 0. What happens when we differentiate the top with respect to h? That's fundamental theorem calculus. That will become 1 plus h to the fifth plus 8. We just plug in the limit as the variable of integration. And then we differentiate the upper limit. We differentiate this with respect to h. That's just 1, right? Over, we differentiate the bottom. That's 1. Okay? So now we can plug in, it'll be what? 1 plus 8 under the square root, which is square root 9, which is 3. Okay, as simple as that. Area of the region enclosed by the polar curve, r is sine of 2 theta for 0, or theta is between 0 and pi over 2, is what? This one, you just plug it into the formula. Remember the area of a sector, that's the formula that I remember to remember the formula for the area of a polar curve. So A is half r squared d theta. Okay, so it'll be half the integral from, they tell us, 0 to pi over 2. R squared d theta, so it'll be sine squared of 2 theta d theta. Okay, how do we solve this? We can do the half angle formula, right? So it'll be 1/4 integral from 0 to pi over 2. Let me be careful with this. I know that sine squared x is half of 1 minus cosine 2x. Okay, we have 2 theta, so it would be this half, so half times half is the fourth. It would be 1 minus cosine of, and I have 2 theta, so it'll be 4 theta d theta. Okay, let's hope I did that right. Then let's integrate. That's 1 over 4 theta minus the fourth sine of 4 theta. Evaluate from 0 to pi over 2. When you plug in 0, the lower limit, those two are gone, right? So we only have to worry about the upper limit. It'll be 1/4 pi over 2 minus a fourth sine of what? 4 times pi over 2. That is 2 pi, right? Sine of 2 pi is 0. So we get pi over 8. 24 is ds. Okay, as simple as that. Particle moves along the x-axis so that at any time t, its position is given by x of t as t e to the negative 2t. For what value of t is the particle at rest? Okay, they give us, this is the position. Particle is at rest is when the velocity is 0. So let's find the velocity. V of t is x prime of t. That is, we need to particle, so first d second plus second t first. First d second will be minus 2 e to minus 2t plus second d first derivative t is 1. Okay, set this equals to 0. Okay, now we can simplify. It'll be, let's clean this up a little bit, minus 2t plus e to minus 2t is equal to 0. We can factor out the e to the minus 2t. Well, what happens when we do that? That'll be minus 2t plus 1 is equal to 0. E is never 0, right? So our only solution is t is equal to half. Okay? That's when the velocity is 0, which means the particle is at rest at t is half, so 25 is C. Okay? For x is between 0 and pi over 2, if y is sine x to the x, then dy dx is equal to what? This is logarithmic differentiation. Okay, because it's some function of x to some function of x power. Let's log both sides. Lny would be ln of sine x to the x, like that, but we can bring this power out in front by properties of log, so it'll be x ln of sine x, okay? Now let's implicitly differentiate, so 1 over y dy dx equal to, here we need product. Well, first d second plus second d first. I feel like this is the third time I said that in this video. First d second would be 1 over sine x times derivative of sine, which is cosine, okay, plus second d first derivative of x is just 1. So dy dx, we just move this y over. It would be y times, this we can write as x cotangent x, right, plus ln of sine x, okay? Does that match any of our choices here? Well, y is what? They give us y, sine x to the x. So it looks like it's e, 26e, yes. Okay. So we do that. Okay. Let's maybe solve one more page and then call it a parts. This one I'm spending a lot of time on, it looks like. This part of this exam, I should say. If f is the continuous strictly increasing function on an interval x is between a and b, as shown above, which of the following must be true? Okay. Then let me see. If I divide both sides by b minus a, is that significant? It probably is. 1 over b minus a, integral from a to b, f of x dx. This should look familiar. This is the average value, okay? So how does that help us here? So we can say average is less than f of b for the first one, if I divide both sides by b minus a. Average is greater than f of a for the second one. And then this is average is f of c for some c such that c is between a and b. This sounds like the mean value theorem. So this should be true. Okay, so let's check that. Okay, so we can already eliminate this and this. Okay, we need to check if 1 and 2 are true now. This is strictly increasing, so this would be, b would be the maximum value. So the average has to be less than the max value, so that's good. Similarly, a is the smallest value, because once again, strictly increasing, okay? So this even illustrates it, right? The average value has to be bigger than the smallest value, okay? So all of them are true. An antiderivative of f of x is e to the x plus e to the x is what? Okay. How to do this? This one looks a little more complicated, but there's probably a trick to it. And worst case scenario, you can just differentiate all of these to see if you get that, okay? E to the x plus e to the x, okay? We want to integrate this, basically, find the antiderivative. So can we do some algebraic manipulation or some substitution? Would a substitution work? Okay, let me just try rewriting this as e to the x times e to the x dx. Okay, so if we let u be e to the x, du would be e to the x dx. So now we can substitute as e to the x, so that's e to the u, e to x dx, that's just du. So this is just e to the u plus c, which is e to the x plus c. Okay. 28 should be e, yes. Good. Okay. Next, limit as x goes to pi over 4, sine of x minus pi over 4 divided by x minus pi over 4. This looks like a special trig limit. If you don't remember that, you could do L'Hopital's rule. That's totally fine also. Okay? Let's just do L'Hopital's rule, actually, because if you plug in pi over 4, it's sine of 0, which is 0. Bottom is 0, right? In BC, you should know L'Hopital's rule, right? So, oh, you should double check that. But since I know it, let me just do it with L'Hopital's rule. So limit as x approaches pi over 4. Derivative of sine is just cosine. Times derivative inside, that's just 1. Over the bottom, derivative of x minus 4, pi over 4 is just 1. Now we plug it in, that's equal to 1. Okay? The other way to do it, let me just do it over here. We can make a substitution, like u is x minus pi over 4. So as x approaches pi over 4, u approaches to 0 then. Okay? So then the limit becomes limit as u approaches to 0, sine of u over u. This is your special trig limit, which is 1. Okay? If x is t cubed minus t, y squared 3t plus 1, then dy dx is t is 1. At t equals 1 is, well, we know that dy dx is just dy by dt over dx by dt. So what's dy dt? Let me write it as 1 over 2 root 3t plus 1 times 3, okay? And then we divide by derivative of this guy, so, or 1 times 1 over derivative of x with respect to t, that's 3t squared plus 1. Okay, so I don't have enough space here, but we can evaluate this at t is equal to 1, right? So we would get what? So this 3 and 2, we would get 3 halves. This square root term would be 1 over what? 3 plus 1, which is 4, so 2 square root 4, which is 2. This one would be 3 plus 1, which is a fourth, something like this. So that should be 3 over... I did something wrong, most likely. It should be a minus, sorry. I think that's why. So 2. Then that is 3 over 8. 30 is B, yes. Okay. So the key here was just remember dy dx is for parametric equations, dy dt over dx dt. Because you can think of it as the dt's would cancel. Okay. For what are all values of x for which the series this guy converges? This we probably want to do the ratio test, okay? So let me see if I can squeeze it in here. Sorry for the delay. Okay. So we want limit as n goes to infinity. Actually, well, this is... I know what this answer is, but okay, let's just do it the long way. If you don't know, okay. Limit as n goes to infinity of absolute value, remember what it is, a sub n plus 1 over a sub n. So x minus 1 to the n plus 1 over n plus 1 times divide by a sub n, meaning multiply by the reciprocal of this, which is n over x minus 1 to the n. Okay, this is a limit we want to evaluate. So this is equal to limit as n goes to infinity of, use properties of exponents, this becomes x minus 1, okay, times n over n plus 1. You can pull out this x minus 1 because it does not depend on n. Okay, this limit is easy to evaluate. It's just equal to 1. Remember, you can do a degree test since it's a rational function. Degrees are the same. Take the ratio of the leading coefficients. Okay, or you can do the long way, which I've done before in previous videos. Okay, so this guy is 1, so we're left with this guy. Okay, ratio test says for it to converge, it has to be less than 1. So x minus 1 has to be less than 1 and greater than negative 1, or x has to be less than 2 and greater than 0. But we have to check our endpoints, right? So we already can eliminate 2 of them. Okay? We have to check our endpoints now. That's the only thing left. So when x is 0, what's our series? It would be, let me write it here, when x is 0, then our series would be 0 minus 1, so negative 1 to the n over n. We know this is convergent. This is the alternating harmonic series, right? That's convergent. How about when x is equal to 2? Then it would be 1 to the n over n, right? This is divergent. This is the harmonic series. So it's including 0 but not including 2. So it's D. Okay, this was the interval convergence problem. Okay, so I'll call it a part here. So please give this video a like if you found it helpful, and please subscribe to the channel to see the next part. Hopefully it's the last part for this test.